right, Miss Patty here. Today we are going to be doing practice on the average atomic mass. So it's also called the isotopic abundance. So the atomic mass for each element appears on the periodic table, and it represents the weighted average of masses for each individual isotope of an element. For example, the atomic mass of carbon is reported as 12.011 AMU, where AMU stands for atomic mass units. Carbon is composed primarily of two isotopes, carbon-12 and carbon-14. The atomic mass is calculated using both the relative abundance and the masses for each of these two isotopes. Using the equation below, the atomic mass for carbon can be calculated. So you do atomic mass equals the mass times the percent, and then the mass times the percent. So carbon-12 accounts for 99.45% of all the carbon atoms, while carbon-14 only accounts for the remaining 0.55%. Since the carbon-12 isotope is more abundant, its mass is weighted more in the calculation of carbon's atomic mass. The calculation of the atomic mass is shown below. So we have percent abundance, which is 99.45. This was percent. We can't leave it like that because you can't multiply that. What you'll have to do is you're going to have to move the decimal two places to the left. So 1, 2. So if you look over here, the first one, you have your mass, which is 12.000 times, and they did what I did. They moved the decimal over, so now it's 0.9945. So you're going to multiply those two. Then you have carbon-14. You have the mass, which is 14.003, and then you have your percent abundance. Well, remember, this is percent. We have to change it. So we're going to have to move our decimal 1, 2 places. So we put a 0 in, and if you look over here, look, it matches up. We've got the 14, and we've got this percentage, and now we made it into a decimal. So once you multiply those, you end up with 11.934 and 0.077. So you can see that you add them up, and you end up with 12.011. That's going to be the atomic mass number of carbon.
One inch is 2.54 centimeters.
Sorry, my phone's being crazy. Okay, so argon has three naturally occurring isotopes, argon-36, argon-38, and argon-40. Based on argon's reported atomic mass, which is 39.948, which isotope exists as the most abundant in nature? Well, if you think about it, what we're trying to do is we're trying to match to this mass number. So you're going to have to think which of those up there is closest to this right here. Once you get that, once you figure out which one's closest to this, that's going to be your answer. And then you need to explain that the fact that the mass number matches the atomic mass number down here means that they are more closely abundant in nature. Okay, so for number 2, find the average atomic mass for lithium if 7.5% of lithium ions are 6 Li with a mass of 6 AMU and 92.5% are 7 Li with a mass of 7 AMU. So we have to find the average atomic mass. That's what we're looking for. So we have the 7.5%. Remember, we can't calculate a percent, but we can change it to a decimal. We're going to move it 2 places to the left, so I've got to fill in that with a 0, and now our percent sign is gone. So we end up with 0.075 times, this guy is talking about lithium-6, so we're going to put a 6 here. Okay? Then we have the other one, which is 92.5%, so 92.5%. Can't leave it like that. We've got to move it over 1, 2 places. So, percent's gone. So now we have decimal 925 times the other guy, which was 7. So you're going to multiply these two. You get a number. You get a number. And then you add these two up. So add them up. And the number that you get will be your answer. So you will need a calculator for this. You can do this with multiple numbers too. You could do it with up to 5 numbers. You're just going to keep doing the same thing like we did here every time and then add them up. That is how you find the average atomic mass.